Adhesive bonding is a joining process in which the film material is used to hold two or more closely spaced parts together by surface attachment. Used in wide range of bonding and silk applications for joining similars and dissimilars materials such as the metals, plastics, ceramics, wood, paper, and cardboard. Considered a growth area because of the opportunities for the increased applications. The adhesive is the film material, non-metallic, and usually a polymer. The adherents are the parts being joined, and structural adhesives are capable of forming strong, permanent joints between strong and rigid adherents. Between the advantages of the adhesive bonding are they are applicable to a wide variety of materials. Also, the bonding occurs over the entire surface area of the joint. Low temperature curing will avoid the damage to the parts being joined. This can be used for sealing as well as bonding. The joint design is often simplified. For example, the two flat surfaces can be joined without providing special parts features such as screw holes. The limitations of the adhesive bonding are the joints generally going to be not strong as the other joining methods, and the adhesive must be compatible with the materials being joined. The surface temperature are going to be limited. The cleanliness and the surface preparation prior to the application of the adhesive are important. Curing time can limit the production rates, and the inspection bonded of joint is going to be difficult. The curing is the process by which physical properties of the adhesive are changed from liquid to solid. Usually, is enhanced by the chemical reaction to accomplish the surface attachments of parts. The curing often aided by heat or and catalysts. Curing takes time, which is a disadvantage in the production. Pressure is sometimes applied between the parts to activate the bonding process. The joint strength will depend on the strength of the adhesive and the attachment between the adhesive and the adherents. The attachment mechanisms are the chemical bonding, where the adhesive and the adherents form a primary bond on curing. The physical interactions, where the secondary bonding forces between the surface atoms. And the mechanical interlocking, where the roughness of the adherent causes the adhesive to become infiltrate into the surface asperities. There are three different types for the adhesives. First one is natural adhesives, which derive from natural sources, including gums, starch, dextrine, soy flour, and collagen. Usually they are applied for the low-stress applications like cardboard cartoons, furnitures, book bindings, and the plywoods. Second type is the inorganic adhesives, which base principally on the sodium silicate and the magnesium oxychloride. Usually going to have a low cost, but also the low strength. The synthetic adhesives, they are strongest and they have a mixture of various thermoplastic and thermostatic polymers. The application methods for the adhesives are the manual brushing and the rolling, the silk screening, the flowing using a manually operated dispensers, using the spraying, or the automatic applicators, or by rolled coating. For adhesive bonding to be succeed, a part surface must be extremely clean. Bond strength depends on the adhesion between the adhesive and the adherent, which depends on the clean surfaces. For the metals, solvent wiping often used for the cleaning, and sandblasting improve the surface adhesion. For the non-metallic parts, the surface can be mechanically averted or the chemically attached to increase the roughness.